Hello, this video will outline the process of data reconciliation using BILCO software. But what is data reconciliation? To illustrate the process of data reconciliation, let's consider a copper concentrator plant with one feed and two outputs, the copper concentrate and the tailings. The solid mass flow rate and the copper content are measured for each stream. For the feed, 500 tons per hour is measured and the copper content is 1.5%. For the concentrate, 25 tons per hour and the copper content is 25%. For the tailings, 450 tons per hour and the copper content is 0.32%. An imbalance is observed on the solid mass flow rate and the copper mass flow rate between the input and the sum of the two outputs. A supplement of 25 tons per hour of solids in the feed compared to the outputs is observed. On the contrary, a supplement of 190 kilograms per hour in the outputs compared to the feed is observed. These discrepancies are arising from sampling and measurement errors. What is the method to determine the copper recovery of the concentrator? One method is to disregard the measurement of one of the streams and to do the calculation based on the two other streams. For example, the mass flow rate and copper content of the tailings could be calculated from the feed and the concentrate. The mass flow rate is now 470 tons per hour and the copper content is 0.26%. The calculated copper recovery is 83.33%. It is also possible to calculate the feed and the concentrate. Two different copper recoveries are obtained. A level of confidence is associated with each measurement. In this example, the level of confidence is better for the measurement of the chemical composition compared to that of the mass flow rate. For the mass flow rate, the level of confidence is 10% for the feed and the concentrate and 25% for the tailings. For the copper content, the level of confidence is 10% for the tailings, 5% for the feed and 1% for the concentrate. Taking into account the accuracy of the copper contents, one possibility is to fix one flow rate and the three copper contents and to calculate the flow rate of the two other streams. In this example, the flow rate of the two outputs are calculated. The copper recovery of 79.69% is calculated. In the same way, we can fix the flow rate of the concentrate and obtain a new copper recovery. However, these different methods take into account only a part of available experimental data. The solution is to resort to data reconciliation, which enables to obtain coherent material balance data using all the available experimental data. A set of coherent data is calculated. The estimated values are not the real ones, but the most probable ones. The level of confidence relative to the estimated values have improved due to the redundancy of the data and the very good accuracy of the copper content of the concentrate. The copper recovery of the concentrator is 79.9%. Once a new file is created in the BILCO software, you can select Graph Drawing from the menu. A toolbox appears allowing you to select icons. You select an icon and paste it into the file. Then you select the Stream button and draw the streams with the mouse. You can assign a name for each stream and each node. The next step is to describe the streams. In this example, we follow only the solid mass flow rate and the copper content. The units are tons per hour for the mass flow rate. Then you add the different chemical elements or minerals that you want to include. In this example, we are only interested in the percent copper. The phase model is defined. You can now enter the measured data and the level of accuracy of each measurement. With BILCO, it is easy to analyze the quality of the measured data. This tool is useful to identify mistakes or abnormal values. In this window, you can adjust the constraint laws. For example, when you have fast transfer of chemical elements between solid and liquid during leaching. The material balance calculation lasts less than 5 seconds, even if you have a very complex flowsheet. A BILCO tool presents the comparison between the measured and the estimated values. A color code helps the user to identify the quality of the data reconciliation. The measured data is represented as a point and its error range. If the estimated value is blue, it means that the level of confidence of the estimated value is inside the level of confidence of the measured value. If the estimated value is black, a part of the level of confidence is partly outside the measured data. A red color indicates that the level of confidence of the measured data may have been underestimated. All the data in BILCO can easily be exported to Excel. Data reconciliation will ensure a better knowledge of the plant operation, providing a coherent set of data and an enhanced level of confidence in the process data. As shown in this example, the accuracy on copper grades has been used to improve the accuracy of flow rate values. With data reconciliation, the accuracy in one point is propagating within the circuit. In conclusion, data reconciliation is the only way to estimate the actual efficiency of the concentrator. It is a decisive step before any further exploitation of the data and decision-making. Don't hesitate to contact CASPEO for more information.